Neural Networks Made Easy, Week 1. This is an introduction to machine learning and how neurons learn. My name is Mark Daniel Registry, and it is a pleasure to be here. All right, so let's get right into it. What we'll learn tonight is what AI, machine learning, deep learning mean. We'll go into the basic structure of a neuron. We'll also look into how the inputs and weights and biases, these terms that you've heard or and even if you're not familiar with them, don't worry. By the end of tonight, you will be. And we'll also look into learns through the loss function and optimization. If you're not getting what these keywords are, don't worry about it. We'll get right into it as we go along. So, artificial intelligence. We hear this term everywhere. What it is, it's creating intelligent machines that can mimic human intelligence. And inside artificial intelligence, you have machine learning, which is an algorithm that enables computers to learn from data. Instead of us having to tell the algorithm what to do, and this is what we've done for so many years, right? We've written codes to tell the code how to run and what to do based on certain criteria. Now, with machine learning, we are able to now give data to the algorithm, and the algorithm find patterns, and that pattern now can be used to make predictions or on future data that you would want to give to that algorithm. And inside machine learning, you have neural networks or neural nets, which are computational models with interconnected artificial neurons. We'll get into that, and you'll see how we connect neurons together to make predictions. And you have deep learning. Deep learning, we won't get much into it, but it's neural networks with multiple layers of representation for learnings. Okay, so we'll get right into it. Don't worry if you are new to these terms. Don't worry about it. We'll get right into it. Now, why tabular machine learning? Why focus on Excel sheets? Why focus on comma-separated files? These are files that we are all familiar with. A lot of us, many of us, we've used Excel. If you've been exposed to Excel, you certainly have information that have patterns, whether you can see them or not, and you can make prediction on those patterns. For example, if you are someone who works for a bank, you might want to know if someone will default on a loan or not. Or maybe you are in real estate, you might want to find the price of a home based on all the data that you have in the area, right? Or if you are in the medical field, you might want to know if a patient is at risk for certain types of complications based on the reaction and the things that they are exposed to. You might want to know if a customer will churn, if the customer will stay or leave a company. So we have data. And like I said before, if you've been exposed to Excel sheets, if you've been exposed to comma-separated files, you can learn machine learning from those type of information. So I plan on making this very relative to you. I plan on making it to things that you've been exposed to in order for you to learn the core concepts of machine learning. So, like I said before, our goal is to build the core or the intuition for core machine learning concepts using data that we have all been exposed to. I would want you guys to understand the essential of data science, workflow, learn how to train, test, evaluate, and set clear progression. So these are things that if you follow us for the next 6 weeks, we will get into, okay? So let's get right into it. Neurons. We see this architecture everywhere. It's on books. It's on the web. Looking at this, you would say, what is going on? What is a neuron? Why do we have an input layer, a hidden layer, an output layer? So tonight, I'm going to go to as low as possible to one neuron, and we will see how the neuron learns and make predictions, right? And I want you guys to learn the core concepts tonight. We will not be focusing on a lot of theories. This 6 weeks course will be based on coding. I want you guys to code. If you are not a strong Python coder, this is the class for you. If you are one, this is also the class for you because everything will be explained step by step. So input data. So we will focus on data we've been exposed to. So for example, let's say we want to create a model. We want to create an algorithm that can detect if a customer will default on a loan or not. And let's say we have age, we have income, and we have credit score. So with that in our hands, we have enough to make certain predictions. We have enough to start knowing if new customers will default or not. Imagine that this table was 1 million rows. Okay, so we will build a model that can make predictions on this specific table. So now neurons. Okay, so this is just a one neuron. Imagine a neuron. Essentially, it's all math, right? And what it is the neuron is the weighted. We'll take the weighted sum of the input times the weight plus a bias. Okay, and essentially what it's doing is it's making a calculation, and that calculation is going to take, for instance, look at the first row. The first row is going to be 25 times W1. W1 will be W1, W2, W2, which are weights. The weights are initially set randomly by the neuron. All right. So now the neuron is going to set those weights randomly, and you have 25 times W1, 40,000 times W2, 650 times W3. Okay, and remember those weights, which are called weights, W1, W2, W3 are called weights. Those weights are set by the neuron randomly during the first calculation. And imagine it's going to make that calculation for every single row in your data. Okay, and it's going to sum it up. So when we look at our table, we call the features, which are our inputs, we call them features. And so in this case, we have 3 features. We have age, income, and credit score. And we can have as many features as possible. The more data you have, sometimes that's good, sometimes that's also not so great. We'll get into that later. But those are, we call those features, and our output, we essentially call it output. In this case, the default column is our output, the row that we are trying to predict. Okay, so inside the neuron, each neuron, as stated before, has in our case 3 inputs. We got X1, X2, X3, which is age, income, credit score. Okay, the neuron has a weight attached to every input. That it will be W1, W2, W3, and the neuron make a mathematical computation, which is the weighted sum plus the bias. Okay, so it's going to be X1 times W1 plus X2 times W3 plus X3 times W3. And as I said before, the initial calculation set random weight, meaning W1, W2, W3 are set randomly. This is the first step. Okay, if you are trying to understand, and I want you guys to really follow along as I explain that concept to you, and you'll learn how neural networks learn patterns from data. So that's the first calculation that takes place, right? So now, after this calculation has taken place, you have an activation function. So we will talk more into the activation function another time. However, the activation function is what makes a neural networks powerful, because without an activation function, a neural network is linear, meaning that is just a straight line. It's only going to detect linear patterns, but sometimes data is not linear. You may have someone with great credit score, however, their income is not so high. You may want to deny them because they may have the potential to default on a certain loan. So activation function really is what helps neural networks learn nonlinear patterns. We'll get more into that another time. So for instance, let's say you have this type of data. If we did not have an activation function, we would not be able to detect any of that data here. We would not be able to make prediction or learn the patterns in order for us to now know, okay, if new blues and red dots come along, we wouldn't be able to know where they fall in the graph. However, activation function allows us to learn non-linear pattern. Write this down. Good information to know as we progress throughout the course. So once you have your neurons, that takes the weighted sum plus the bias. You have the activation function that allows you to learn nonlinear pattern. So now the output of that is a predicted Y. Okay, it made a prediction on whether or not all of the rows. It made a prediction on each row, and that prediction is going to be compared to the actual value of that's from the table. So your loss function is going to look at how far off your prediction is from your actual value. Imagine you are playing basketball, and every time you shoot, the distance from the hoop is your lost. So if you do an air ball and it's 2 inches away, then your loss function will say, hey, it's 2 inches away. Or if it's at 10 feet, your loss function will say, hey, that's a big loss. It's 10 feet away. So your loss function, once again, it tells your model how far off it is from the correct answer. Okay, so inputs, you run your inputs to the model or to a neuron. It goes to an activation function, which learns nonlinear patterns, and then it spits out a predicted number. And then that number is now compared to the row and says, hey, you are X amount of values off from the actual value that's from the table. So now, the next step, what a neural network will do is, this is called backpropagation. This is a concept that a lot of people have difficulty understanding. So let's backpropagation, it's like a feedback. What it does is it's going to go back through every single weight that's in the network, or that's in your neuron, that's in your model, and it's going to inform each of these weights the effect it has on the loss that was just calculated. So these feedback are called gradients. Okay, so backpropagation does not update the weight itself. It calculates the gradient. It calculates by taking the partial derivative of the loss function in respect to every single weight. Okay, and it will inform each weight. This is the effect you have on the output. Okay, and it calculates this gradient. That gradient value is going to be passed along to an optimizer, and the optimizer is going to adjust the weight and the bias in the network so that the loss can be increased. So imagine ChatGPT 4 has 1.7 trillion weights. So the optimizer is like So right now we have 3 weights, right? W1, W2, W3. ChatGPT has 1.7 trillion. So the optimizer go ahead and adjust each weight based on the effect that it has on the based on the gradient that it received that was calculated by the back propagation. So the optimizer's job is to reduce by adjusting weights and okay. So before we go into coding, I hope you guys in this video will be shared on YouTube, so you can go back and look at this again. But imagine you have your input, excuse me, which goes into the model. The model have weights and bias. It goes out into the intervention function, which allows the model to learn nonlinear pattern, spits out a prediction, how far off or how wrong you are based on that predicted value. The loss function makes that calculation to the optimizer. Also back propagation takes place where every weight and bias now a gradient is calculated where we now know the effect of each weight and how it affects the loss function or the loss that just came out of the loss function, goes into the optimizer, and the optimizer does the changing and it's like a knob. It turns up weight 1, it turns down a little bit weight 2, and I'll keep it the same, and then it makes that calculation again on the same data to reduce the loss as much as possible. Like I said, I want you guys to code. I want you guys to code. I want you guys to learn this. I want you guys to be able to take an Excel sheet, a comma separated file, and start finding patterns. So head to Colab. We will look at this simple data. We have our study hours, and we have test scores. And our goal is to, instead of writing code to tell the algorithm what to do, we will give the algorithm role, I guess, role number 2, 1. We will feed it into the algorithm. It's going to find, and it should be able to tell us how many, or what was the test score for someone who's for 9 hours or 10 hours or 11 hours or 15 hours. All right. So let's head over there now. I am going to share my, now I am going to share my screen. There you go. Now, can you guys, let me see. All right, so now I am not sharing this screen. So our goal is to train a cell model, okay, from this base data based on the architecture that we just saw, based on the in order for us to now have that model spit out future predictions for us. So I went ahead and added the section and next week we'll go into what it started. That requires tensors. I require tensors for X and like I said, we will go into more into tensors. It's the tensor is a container. What it does is the whole numbers and we make predictions. The data numbers, so it tells the tensor that it flows. Okay, and if you're on a 32-bit machine, you have a 32-bit or 32 decimals, or 64 decimals, and so on. Then you have your Y.